All right, what's up, everybody? So what I'm going to do is run you through the four-step process for a significance test for a population proportion. I'll often just abbreviate that as the z-test for p. So we have our four-step process. These four steps are pretty similar to what we did for a confidence interval for a proportion. What we do in each step is a little bit different. I'll walk you through an example at the end of this as well. So step one, you're going to identify your parameter of interest. So you're going to write down, in this case, what P stands for. You're going to write your null and alternate hypotheses. So I'll review that. Step two is your conditions, and then you're going to name your procedure. So as usual, we need our random sample condition. We also need a normal sampling distribution. You test that by checking n times p and n times 1 minus p, both needing to be greater than or equal to 10. And then there's another condition about independence. So you do need to assume that you have independent sampling. One way to think about that is meet the condition that the sample is no more than 10% of the population. A quick way to check that is just to think about your sample size and multiplying that number by 10. So if your sample size times 10, if it's reasonable that your population is that number or bigger, that'll satisfy this independence condition. Step three, you're going to carry out the procedure. Again, I'll walk you through that. And then step four, interpret your results in the context of the problem. All right, so that's your four-step process, and I'm going to apply that now to an example. So I'll read it first, and then I'll go through the four steps. So a large local prison is trying a new program to reduce crimes committed by recently released prisoners. Nationally, the proportion of prisoners that return to jail in less than 1 year is 0.61. The local prison takes a random sample of 42 released prisoners and found that 16 returned to prison within 1 year. All right, so 16 of the 42. It says, does the program seem to work? Test at alpha equals 0.05. So again, this is the Greek letter alpha. Alpha stands for the level of significance. So we're going to be using a 5% level of significance, or an alpha value of 0.05. All right, so what I like to do first before I start my four steps is just to notate the appropriate information. I'm going to start with my n value of 42. I also have a sample proportion, which we call p hat, and that's the 16 out of 42. And that number comes out to be 0.381 as a sample proportion. And then I also know that my alpha value is 0.05. Okay, so I always like to write that stuff down first before I start into my four steps. So my first step is I'm going to identify my parameter of interest, and then I'm going to write my hypotheses. So my parameter of interest, this is a proportion problem, so it's going to be P, and P is, in this case, going to represent the true proportion of local prisoners So I know the proportion for prisoners nationally, but I'm specifically concerned about the local prisoners, so I want to put that into my identification of P. So it's the true proportion of local prisoners that return to prison within a year. Okay. So then our null hypothesis, so then I need to write my hypotheses. I always want a null, so hypotheses are written in pairs, always with a null hypothesis and an alternate. So H sub 0 and H sub A. And since I'm doing it for P, I'm going to start both of my hypotheses with P. My null hypothesis always gets an equal sign after my parameter. And then what I'm going to do is I'm going to set that equal to the number that I'm going to assume to be true about these local prisoners. And what I'm going to do is I'm going to assume that the local prisoners have the same release percent or return proportion as they do nationally. So I'm going to set this number equal to 0.61. And that number just comes from this national percentage here. All right, my alternate then needs to have the same value here. So I'm still going to write that as 0.61, but now my options for my, instead of an equal sign, is I need to use an inequality sign, either a greater than sign, a less than sign, or a not equal to sign. So what I'm going to do now is think about my problem. I'm trying to see if this return rate was lowered, right, because they're trying to reduce crimes. So I want to try to show, for this local prison, is that proportion actually less than the national proportion? So that's going to be a less than symbol there for my alternate hypothesis. All right, so that's step one. I got my parameter, I have my hypotheses. So now I can move to step two. So step two, I need my three conditions. So random sample, normal sampling distribution, and independence. So I'm going to first make sure that a random sample was taken, right? So that's here, so yes. So I'm going to just write the sample was randomly obtained. Okay, and then I'm going to check my conditions for a normal sampling distribution. So I want to think about n times p and n times 1 minus p. Okay, so n is 42, and now p, I want to use my p from the from the null hypothesis. So instead of using my p hat value, and that's a common mistake, is people will use the 0.381 instead of the 0.61, but we do want to use the assumed population proportion here. So that's going to be 42 times 0.061, which is 25.62. Okay, that is greater than 10, so that's check. Okay, now I'm going to check n times 1 minus p. So I'm going to do 42 times 1 minus 0.61, and that is 16.38, also greater than 10. All right, so I do know that I can use a normal sampling distribution because those two values were greater than 10. And then lastly, I want to check this independence condition. Okay, so the sample is no more than 10% of the population. So I took 42, so my sample size was 42. If I multiply that number by 10, I get 420. So basically I want to think about, is it reasonable to conclude that this population size was greater than 420? And I'd say yes. It does tell us that it's a large local prison, so we can probably assume that there are more than 420 prisoners. So it's kind of a judgment call in this case. I think it's okay to assume that. So we can say here, it seems reasonable that n equals 42 is less than 10% of the local prison population. Okay, so now then the last thing to do in step two is to name your procedure. So we can say now that the conditions for a z test for p are met. All right, so step two is complete. All right, so now we can move on to step three. So step three is where we actually carry out the procedure. So you basically need three things for the procedure. You need a picture, a test statistic, which in this case is a z-score, and you need a p-value. So we're going to start with the picture. So two things that we need for the picture is we need the mean of the sampling distribution of p hat, mu sub p hat, and if you recall, that is equal to p. So this number is going to be 0.61, so that's where I'm going to center my distribution. Also then remember I can calculate my standard error, so that's sigma sub p hat, and that is big square root p times 1 minus p over n. And again, you're using 0.61 in for p there. So I'm going to put those numbers in, divide by 42 square root, and that's going to give me about 0.0075. Okay, so that is going to be my mean and standard error. So now I can go ahead and draw my normal distribution. So this is going to be my p hat axis, and then I'm going to have a corresponding z-axis. Okay, so then I'm going to go ahead and draw my roughly normal distribution. It's going to be centered again at 0.61 with a z-score of 0. And then I'm going to count up by that standard error in each direction. So I'm going to do a little bit of rounding here, but this is going to go up to about 0.69. This is about 0.84. So then this will go down to 0.53 and 0.46. So -2, -1, 1, 2. I'm going to double check my calculation there for that last one. And sorry, this should be 0.76. All right, so now what I'm going to do is I'm going to place my p hat value on my distribution. So this is the first time I'm going to be using this p hat value here of 0.381. So that's going to be pretty far to the left here. I'm going to extend my picture a little bit. And 0.381 is going to be about here. So that number is 0.0381. Okay, and I also know that this is a less than alternate hypothesis. So because it's a less than alternate hypothesis, we call this a lower tailed test. So we shade to the left. Upper tailed tests are usually going to be on this side of the distribution, shading to the right. Not always, but you're always shading to the right for an upper tailed test, shading to the left for a lower tailed test. Two-tailed tests, you actually shade both sides, and that happens when you have a not equal to alternate hypothesis. Okay, so then I have my picture set up. Next thing I'm going to do then is calculate a z-score. So the z-score is going to be my p hat value minus my population proportion, so the mean of my sampling distribution, and then I'm going to divide by my standard error. And if I do that, I get a z-score of about -3.04. Right, and that matches my picture here. It's about 3 standard deviations to the left of the mean. Okay, and then my last bit of step 3 now is to calculate a p-value. So p-value is basically the probability of getting a sample statistic less than the one that we got in this sample, again, because that was a lower tail test. So a p-value then just comes, it's a probability, so it just comes from normal CDF on the calculator. So what you're going to put into normal CDF is, so normal CDF, remember normal CDF is second vars down to normal CDF. Your lower boundary, remember we use -1e99 for a really negative value. We're going to go to 3.04. Keep the mean and standard deviation at 0 and 1 since we are using a z-score here. And then that will end up giving you a p-value of about 0.0012. So pretty low, certainly less than 1%. Okay, so that's your p-value. So again, step 3, just to recap that, you want to picture a z-score and a p-value. We have all 3 of those. Okay, so basically we're done with our calculation. So then step 4 now is where we compare our p-value to our alpha value. So in this case, our p-value was 0.0012, and that number is less than our alpha value of 0.05. So what that tells me is that my sample statistic was in that lower 5% of the sampling distribution, which means that it would be rare to occur if the population proportion was actually 0.61. Okay, so because it's rare for that sample proportion to occur, it means that we probably have evidence that the null hypothesis is false, so we can reject the null hypothesis, which then will give us evidence for the alternate hypothesis. So that's basically what we're going to write here. So that since the p-value is less than alpha, we are going to reject the null. So we can just write that out. And then what we want to do then is then write in context what that tells us about the problem. So what we can say then is that, and you want to just kind of use this same wording I'm using here. So there is significant evidence to conclude that the proportion of local prisoners, right, and again, we're doing our test for the local prison, so we want to make sure that we include that in our statement here. So there's significant evidence to conclude that the proportion of local prisoners who return to prison in a year is less than 0.61, which remember was that national proportion. So again, there's significant evidence. So because we rejected the null, there's evidence for the alternate hypothesis. And if we put the alternate hypothesis in context, we can say there's significant evidence to conclude that the proportion of local prisoners who return to prison in a year is less than that 0.61 number. So again, if we go back and answer that original question, does the program seem to work? Well, yeah. The proportion for the local prison we can conclude is lower than the national proportion of 0.61. So we can conclude that the program does work. All right, so that is your 4-step process for a z-test for P. Thanks for watching.